This is part number 2.
Okay, so let's, yes. So thanks, David, for the slide. So we now switch to the next part, which is the speech recognition. So again, these are all the details that you need, but we will just straight head forward to the speech recognition. Okay, so first let me explain, before I start show you how the speech recognition module works. So let me explain a little bit like what is the things that happen during speech recognition. So speech recognition is a process to extract speech contents from humans' voices. So we input from human voice. So you try to capture what human user is saying. Okay, your robot try to capture this voice. Then after that, you try to extract. So the system will try to extract the content of this voice. So this whole process, we call it the speech recognition. Or in a more general term, normally people will use this term ASR, automatic speech recognition. So this is the terms that you may come across in a lot of technical paper or related to this speech recognition. So an automatic speech recognition system converts spoken words into text. So it's a reverse of speech synthesis. So you want to convert whatever that's spoken in voice back into text. So that is what you mean. Right, and the process is something like this diagram. But just want to tell you that this speech recognition, there are many frameworks, many ways of doing this. Okay, so this is not just the only way of doing this. So there are many ways. So, but over here, I just want to bring one simple reference to show you the general way how this speech recognition is worked, right? In technical. So first thing is we have the voice signal. So from the left-hand side, we have the voice signal. So you can treat it as a wave file or treat it as a signal. Okay, so it is actually a signal. Right. Then we input this signal into our machine, which is you through the mic, then you through the sound card, then it convert from analog system to digital system and so on. Then you have a signal, right? You have electrical signal. So once you have the signal, then we can perform all the signal processing technique into it. Okay, so you know there are many things that you can do with signal processing. Okay, so so over here, what we do is the first step is do feature extraction. So with the given voice signal, we try to extract the features, so certain features, because like in every word that we pronounce, okay, there are certain waveform that we can actually extract, and we can group them or we can extract them as a features. So you can identify certain word or certain pronunciation as a using the features. Okay, so we extract the features. Why we need to extract these features is because we want to do the analysis. Okay, so over here, after the feature extraction, we have two things that you can see on the diagram. One is go to the recognition, another one to the training clustering. Okay, so in order to do the recognition, first we need to have a template library on these features. So this template library will explain, like for example, certain features represent certain words. Okay, I'm telling you this in a very simple way, but technically it might not like this, but I'm telling you in a very simple form so that every one of you can understand, right? So I use it in a very non-technical word to explain this whole process. So in the template library, you have a lot of like, it's like a big database to match between certain features represent certain word or certain particular information about the text, right? So in order to build this library, first we need to do some training or we need to do some learning, okay? And for this training or learning, we can use a lot of methods. Okay, we can use a traditional method to do this learning, like neural network and so on. And up to now, we have the for like reinforced learning and so on. We can use a lot of learning techniques to do this. And also like recently, we have the deep learning way of training and learning on voice and so on. So there are many ways to do this learning. But the important concept is we will have a database about your voice and also what is the meaning. Okay, we have a big database on that. Then once we have this library, we can do the recognition. So the recognition is as simple as pattern matching. So you for example, you know certain word is written and the features look like this. Then we can compare with the features extract from the mic, and you try to do pattern matching, which is you try to match between these two and find out the similarity. If this input match with certain unit in the template library, then it is considered like it is maybe the system will estimate like this is the matching or the correct content from your speech, right? So this is a pattern matching. And for this pattern matching, we also have a lot of techniques to do the pattern matching things, right? So we can do a lot of way to do the classification and so on, right? But we understand that this whole process is an estimation. It's not a definite answer. So that's why when we do recognition, we always have a confidence level. So the system will tell you based on the calculation, the matching rate is something like maybe 60% is very high or 30% or something. So it will give you a confidence level. So not always it will give you like, okay, this is 100% matching. This voice means this content, okay? We always have this confidence level that tell you how similar is this two, but the system cannot tell you exactly what is the answer. So from there we have the decision. So we will the system will give you certain word like, okay, with the given input, this will be the possible answer with how much confidence level. So always we have this kind of output. Then you need to deal with this output, right? So I will explain more after about this how to handle with this result in the next slide. Okay, so this is the whole idea on how the speech recognition works. Okay, right. So let's look at a real example. Next slide. Okay, so in order to start, first I introduce you what is the tools that we use. So over here we use the CMU Speak, which is a system for speech recognition. But if you head to the website, it actually have a lot of tools and module within the speech recognition, because speech recognition is a big system. So the CMU Speak is a big framework that will provide you many tools in the aspect of speech recognition. So speech recognition is not just about the recognition itself. It has many more things. For example, like the training tools, how you want to train the voice, how you want to create a template library, and so on. And also we have tools to make the system adapt to your voice or slang. For example, like I might not saying the very proper US English or UK English and so on, but I can actually train the system to adapt to my slang, to adapt to my pronunciation and so on, right? So we have that kind of module as well. And we also have tools to actually extract from a particular person or a group of person to come up with a specific template for a specific group of people and so on, right? So you can do a lot of things. And also for this framework, it is not just limited to English, okay? It actually able to support, for example, like US English, UK English, Australian English, and so on. And not just only English, it can support like other languages as well, French, Germans, and other things as well, even including Chinese and so on. So what difference are the database, the language model, and so on? The framework and the recognition algorithm, everything look very similar. Okay, so it's just that your database might change when you change, like over here we call it the language model and so on. So if you're interested to know more about all these speech recognition tools, you can head to the CMU thing to know more about other tools. But over here, in all the tools, we will show you how to use one of the very useful tool for our application, which is the Pocket Spin tools. So this Pocket Spin is part of CMU Spins that is good. It's a very lightweight system that we can do speech recognition on very simple machine, for example, like a laptop or even on a handphone. Okay, because we know that just now from the diagram, you understand that we need a very big database, because if you want to recognize all possible words that will be spoken by your user, you will have a very, very big database, because you need to contain all the words and all the features and all the things. And then in order to do the pattern matching, you require very high, computing power, because you are going to compare. For example, you try to imagine you have a very big database and I give you an input. Then you need to have a very optimized and way to do the pattern matching for this particular word with your big database. So the computing power, the database size, and so on require very big infrastructure in order to do this recognition. So it is very, very hard. Okay, so for CMU Spin, they come up with a portable model, a mobile model, tools that you can use it for small devices, for example, your laptops or handphone and so on. So that is the Pocket Spin. So over here, we use the Pocket Spin. And over here, we also use the raw, I show you the link to the ROS wrapper that already wrapped the Pocket Spin. You can head to that website to know more about the Pocket Spin in ROS. Okay, so we will use that tool. Okay, and over here, I will also want to explain to you one additional concept, which is the offline and online. So over here, I've written offline. Okay, so why offline? It's because just now you understand that in order to have very big database and also very big computing power, most of the cases you have to reduce everything is because like you want to run it on a simple machine like your laptops or handphone and so on. So if we do in that way, we are doing the offline way, which is everything run on local resources. You run on your local database, you run on your local computing power. But there is also a way that you can run this function on simple machine, but having a very big infrastructure. How? By having online system. So which is from your laptop or from your phone, we connect to a cloud system that you have very big server infrastructure up there that can contain a very big database. And that is the online method. And recently, in recent day, all the, for example, your series, your OK Google, your Google Home, and so on, they won't work. Okay, so if you turn off the Wi-Fi or you turn off you turn to airplane mode, the series is not going to work anymore. It's because this system they use not the local resources, but they use the cloud resources in order to do the speech recognition. So which means they send your send your voice to the cloud, and then they do the processing. And this is the online method. So in today's class, I will show you the offline method, which is you can run everything on your laptops and everything. And later on, Jupyter Robots will show you how to use the online way. Okay, so our system, we also can do the online way, which is we can connect our system to online resources, for example, Google API and so on, to do the speech recognition. But that is the additional part that will be presented by our colleague from in Jupyter Robots. Okay, so now I show you this offline way, which is you can do everything on just your laptop. You can even turn off your Wi-Fi and it will still work. Okay. But the challenge is we have very small database and very small computing power. So how to make it work? That is the constraint. So I will explain the constraint and also how we build local language model by showing you this example. Okay, so first is like we can do the installation. So if you are using the VirtualBox model, you don't need to install anything. You can skip the whole installation part, the Pocket Spring, and then also the ROS package example for Pocket Spring. Okay, so you can skip all this step. And also the language model. Why I show you all these things is just in case you want to know what are the things that you use. So these are the things that you, and also for all the other users that don't use the VirtualBox, you can install by yourself by going through this. Over here, I also want to show you the language model. Okay, why I want to show you the language model is because I want you to understand that currently our setting, I'm using the UK language model, which is a UK English. Sorry, US English language model. So I downloaded from there, and that is the language model that I use. That's why our recognition that later on I demonstrate to you. David will demonstrate to you. The recognition will based on the US way of English pronunciation. Okay, so that actually make the pronunciation a bit different from us. I mean, like at least me and David, we speak English in a very Asian way. So sometimes the recognition don't work is because like our pronunciation don't fit the initial language model. Okay, but anyway, we need to understand all these things. You need to understand like what language model you use, what kind of pronunciation you need, and so on. The UK way, US way, or the rest of the thing, the English, they are all very different. So for recognition, you actually need to take account of these things, the slang, the way of pronunciation, and so on. Okay, so let's go to the next slide and I will show you the actual example. So the first thing is, in order to use all the offline speech recognition, the first thing you need to understand is the database. Okay, the speech recognition database that you need to provide for the system to do the recognition, which means your system is going to recognize the input based on the database that you created. Okay, it need to refer to a finite local database. So for example, over here, we prepare a very simple example in this Pocket Spring folder. So over here, you can see we open up this DIC, the dictionary file, and you can see we only have a few: back, forward, full, half, left, move, right, speed, stop. And then the behind one is actually to indicate the pronunciation. And over here, I want to show you one example. The English and the US English and the English that we speak might be different. So for example, for me, when I say stop, I have the O sound, stop. Okay, I have the O sound, that is my pronunciation. But when I run this example, the stop is very hard to get recognized. Okay, until I open up this file and I look at how to pronounce the stop is S-T-A-P. So it's actually stop. It's not stop. So when I try to say stop, and the recognition become better. Right. So that is the things that you need to pay attention and put extra attention on this language model and stuff, because like you need to really know what kind of language model that your system use. So over here, I show you this. So the first thing is I prepare this language model, which is a finite dictionary for the system. Then the next thing is I run. Okay, so over here, the speech recognition, I will show you two examples. One is the KWS, and another one, which is the next one, which is the LM. Okay, so KWS is one of the speech recognition method in Pocket Spring for you to do keyword spotting mode, which is over here you can indicate certain word, and when you run this system to hear a long passage, for example, a speech and so on. So the system will try to pick up certain keyword, right? You pick up certain keyword and tell you like what are the keywords that appear in the speech, right? So this is a keyword. And the second one that I'm going to show you later on is a language model, which is a much more appropriate example that we use a lot in our RoboCup development. So I recommend you to use the second one later on that I show you, but as an example, I show you this keyword spotting mode as well. Okay, so David, can you now try to run this? So in order to run this KWS speech recognition in Pocket Spring, the launch file is quite long. Okay, why? It's because like you can see, first we launch the Pocket Spring package, and then inside there we have a kws.launch. This one you understand. But later on we have two arguments. First, in order to run this KWS, you need to tell first what is the dictionary file, which is the file that I just showed you. So the dict is equals to. So you need to point to exactly where is this file located. Okay, the full path. Okay, so David try to key in the file. You can find this file in the Pocket Spring folder. Okay, so the first file is something.dic. So this dictionary file need to be specified when you run this KWS launch. Okay, then the second file that you need to specify is the KWS file, which is the KWS list file that you need to specify for your Pocket Spring to work. Okay, so once you specify these two and everything correctly, then you can see everything run nicely without any red color error message, and that is good. Okay, so now it is ready. So now we use another terminal and we do the ROS topic echo KWS data.
Jeffrey,
Yes.
I need to restart the virtual box. There is something wrong with the system.
Okay.
I need to restart the virtual box.
Okay.
2 seconds. Okay.
Right.
Sorry.
So let also for the meantime, when David try to restart the virtual box, so let me explain a little bit more. So to run this Pocket Spring KWS mode, we need to specify the dictionary and also the KWS list. So these are the two things that you need to specify. And I make the slides to let you run for the first time. To indicate this two file explicitly is for you to understand that you need to have this file, because previously when you run speech synthesis and so on, you don't need to prepare any file or any database. But particularly for this speech recognition, you need to prepare this database. So that's why I do it explicitly as a first. But in the second slide later on, I will show you how you can define this path in your launch file, and later on you can no need to type out the long command anymore, right? Okay, so now David try to run again. And the third one you can see over there is a ROS topic echo KWS data. So this is to print out the ROS topic of KWS underscore data. And this KWS underscore data is the topic containing the result of this speech recognition node. So later on, you no need to modify any of this KWS programming. You can just use it as it is. All you need to change is your database, which is the word that you want, and also you try to subscribe to this topic so that you can use the result. So that is how we use ROS. We feel like from my previous explanation, ROS is the way the node architecture is one of the way that you can use a lot of things. You can reuse a lot of functions without changing the internal code. So now this is one of the examples. You can use the speech recognition node or package without change any coding inside there. All you need is you just need to modify the database, and also you just need to subscribe to this topic and channel this message to your application. All right. So
Excuse
now
me,
I think like David can show you. Okay, so David, please show the example.
Okay. Stop.
I think like it's too noisy.
Oh, I will.
So over here, two important concepts you need to know is the detection rate and the accuracy. Okay, for recognition, you need to understand the balance between detection rate and accuracy. Detection rate means how frequent your system able to detect certain words, right? How frequent or how good your system able to detect is the detection rate. But how accurate is the answer is the accuracy, which means whether is the detection result correct or not correct. Okay, because we might want a very high detection rate, which means whatever that you say, the robot is able to catch that you are saying something. But we also don't want false detection. Okay, we don't want false detection because if the robot can hear a lot of things, but hear a lot of noise as well, and tell you a lot of unnecessary thing or not correct thing, that is meaningless for you as well. So we need to make sure that we try to balance between detection rate and also the accuracy. And here comes in the confidence level and also your mic setting. How sensitive you want to adjust your mic. Because if your mic is too sensitive, it will pick up every single noise and it will tell you this noise is certain result and so on. But that is actually a noise. It's not something you want. Okay, so you might need to like make sure that you have appropriate detection rate and also very high accuracy. That is what you want. And this is a balance. So you cannot put like...
Excuse me, doctor, I have a question.
Yeah, can you please put your question in the group chat? Thank you.
Oh, okay.
Okay, right. So yes, we try to like maintain these two. So the detection rate and also the accuracy. So that is what you need. So there are many things that you can play with. For example, your mic setting, your gain, and also the way how you create your database. Okay, for example, just now you can see like the back, stop, and everything. Many words are very similar. So the detection rate might, the accuracy might be not very high for that. Yes, at least you need to tell me what is your error. Most of the cases is because you input some spelling mistake. A lot of cases is not a spelling mistake, so you need to check. Okay, David, can you please show us? Okay, David, please show us.
Stop. Left.
I think still very noisy.
Right. Yes, a little noisy.
So
could you mute your microphone?
Okay, so let me mute my microphone.
Left. Right. Back. Stop. Forward. 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 Okay.
Okay, so you can see, so that is roughly the accuracy. And this demonstration, what I want to say is like you cannot always take all the result from the recognizer. So the recognizer is only a suggestion of what possible the system here. You need another layer to filter out certain false detection as well, right? So that is something that I will explain more later on when you need to do your assignment for application. But over here, you remember my word that you cannot always channel this result and use every result as it is correct. Okay, because it is very, very possible that we have very high false detection in this. So what you need is like you take this as a estimation and try to do the logic for your decision making, whether is the detection or the estimation correct or not, in order to control. But now we can use this. Okay, we just ignore about the false detection. We can just show you how we can use this to control robots. Okay, so can you show the demo on how to control the robot?
Okay.
Okay, so what David tried to do here is like, first we run the Gazebo, which is a simulator indoors, so that we have the environment and also we have the robots. So this is very important because we need to show you how to control the robot without involving physical robots. So we need to use a simulator robot. So Gazebo provides us a simulated environment and also simulated robots to show you how we can control robots. So now there's a command over there, ROS run pocket spring voice control example.py. That is actually a node to channel the result from the recognizer to the control of the robots. So you can see like when we say left, right, front, back, when we get the result, the robots start to move.
I will try say something. Could you please mute your
Yes.
microphone?
Okay.
Forward. Left. Right. Yes, right. Left. Back. Forward. Full speed. Full speed. Left. Left. Right. Right. Okay, that's all. Thank you.
Right. So you can see it actually works. So we can actually use the voice to control the robot, and this is how you achieve. But we found a problem, which is the accuracy, right? So the accuracy is actually making all this thing a bit not how to say, up to our expectation, right? So you need a more accurate system for the speech recognition. But don't worry, let's look at the other option. Okay, so we have the another option. So I will skip the the source code implementation for this part because I will come back later on. But let's look at a more better example. David, let's go to the LM mode.
Okay, I will shut down this one.
Okay, so let's look at the other example, which is I suppose will give you a better result. So for the second mode for this pocket spring that we want to show you is we call it the LM mode, which is the language model mode. So this language model and the first language model might be a bit different. So this language model is we define the sentences that we want. Okay, the sentences that we want in a corpus file. Okay, so first we show you the corpus file, which is the database that we created for this particular application. Okay, so we head to the RC speech, which is our example, and inside there is a RoboCup folder. So this RoboCup folder contains the database that we created. Okay, so you can see we have many lines with sentences. Get me a green tea, bring me a lemonade, and so on. And we have also simple, for example, thank you, yes, no, follow me, stop, and all these things, and also go to the living room and so on. So we have quite a big list of instruction, right? So these are the very typical instruction that you want to give to your robots. Okay, so once we prepare this, which is in especially our RoboCup competition, we want all these things, right? We want to recognize these kind of sentences. So we will list down all the possible sentences that we want. Then we need then with this database, maybe you want to keep this as it is and use a terminal. And let's try to run the LM application and see how is the recognition. Okay, so the same thing, we do the ROS launch, and then this time we are running our package, the RC Home EDU speech, our package for speech module. Then inside there we use the LM, which is the LM tools that for speech recognition. And similarly, we need to specify two arguments. First is the dictionary file, similar like just now. But the second file is the LM file. So instead of the KWS list, we now specify the LM file. You can look at the LM file, but it is generated file, so it is not very readable. But it is the content generated from the corpus file, which is I will show you how to do the generation later on. Okay, so you can observe that David actually run part of the input is because like David used the tab in order for the autocomplete. So this is a very important and very useful tools in Ubuntu for input is because like when you tap, you make sure that your input is correct. Okay. All right. I'll mute my mic. You can do the demo.
I also open another terminal to show the echo for the topic. So I will say something according to the command line, something like go to the living room, go to the kitchen, okay, go to the bathroom, bring me the green tea, bring me the milk. My name is Jessica. My name is David. My name is David. This is a sofa. This is a bed. This is a couch. Okay, that's all. Thank you.
Well, actually, there is. I still remember one student actually said that. Okay, this is okay because
I think the reason may be in my pronunciation of English.
Yes.
Thank you.
So actually, when I give this to my class in China, so there's one student say that this might be a good. We can develop a good application for training of English pronunciation.
Yes,
So
I
to
suggest
train, yeah.
all of you to try to pronounce according to the RoboCup list.
Okay, right. So this is some of the example that you can say. So over here, the recognition work and the whole thing work. It's just that the detection. Sorry, the detection is okay. It's just the accuracy is not very good. But you can see that partially the sentence got correct. For example, my name go to bring me. This one is okay. It's just the behind the keyword maybe is not so good. It's because like we have very similar word behind it. Because for example, like bring me a cheese and bring me something which is very similar. So sometimes it's not able to correct, catch all the words in one sentence, but some of the word in the sentence might got correct, right? So always, and another strategy that I want to explain here is like, actually very similar like human. When you listen to someone saying something to you, you might don't listen to the whole sentence. Okay, although this is not really appropriate and correct, but this is very natural things to happen. We always capture only the keyword. So for example, I tell you, and you can hear only just a few keywords, then you try to fill in the rest and try to estimate my meaning. Okay, a lot of people try to do that, and this is very natural way of doing. So we should also develop a robot in order to just pick up a certain keyword and try to estimate what is a possible meaning of the words, of the sentence, of the instructions, and so on. And that is a better way to actually counter the imperfection in recognition, because it is almost not possible for any of us to come up with a system that have 100% accuracy for speech recognition. It is not possible. Okay, you will get like 90 plus, that is the max, and so on. So you always miss a certain words and so on. But you need to make your system robust enough to, even though we miss some of the word, we can still confidently understand your meaning that you want to tell us. So that is more important. So that is a strategy. So for speech recognition, it is not just about the recognizer. It is not just about the result from the recognizer. You need to put extra effort to make the understanding. Okay, the understanding part is actually more important than the recognizer in order to understand the content from the user. The recognizer is just a tool to help you to pick up the keyword so that you can, how to say, do the decision making. Okay, so you need extra effort on how to understand from the keyword and also the logic. Because like when you're asking something, for example, you're asking someone name, and that person tell you numbers or tell you food name and so on, or plant name, maybe it's not very appropriate because you expect a human name and so on. So if you got this kind of result from the recognizer, you need to have mechanism to make certain filtering for false detection and so on. Okay, so this is something that you need to put extra effort in your coding, which is I'm going to explain to you about the coding. Right. So, but before we say about the coding, I would like David to show us so how actually we can build the database for this example. Okay. So just now you saw the corpus. So now the next step after you have the corpus, you need the LM and DIC file. But how to generate these two files? Okay. Over there on the slide, I show you First is like you create a corpus file. Okay, so you can write any sentences you want the robots to recognize. Okay, so you can build your corpus file. Then you open up the website for this CMU Spin. I mean, yeah, CMU Spin, it got its own website in CMU. The computer science department, it have this for the speech group. That it have a website for you to upload your corpus file, and this web page will convert your corpus into a numbers of file for your recognition. Particularly, the file that we need over here is the LM and DIC file. Okay, so first it's like, okay, you gedit, or you can use any editor. You try to edit the corpus file, or you can create new corpus file. Okay, it's up to you. You can change the path as long as you leave the correct file. It's okay. So first step you need to do is you create the corpus file that you need. Any corpus files. All right.
I have a backup the RoboCup compass, so I can change the maybe I delete some commands in this file. Make it simple. Okay. Jeffrey, can we go on?
Yes. Right. So once we have the corpus file, we open up the website. You can access the website from this link. Right. So this is the web page that you need. So over down there, you have the browse there. You can specify. So which means you upload your corpus file.
So you can keep you can keep the file as any place you want, not absolutely according to this file device. RoboCup, this one, and compile.
So once you select your file, you just click compile knowledge base, then you will get a zip file. Sorry, not a zip file, it's a compressed file. So it's a file. So this file will contain all the files that have been generated, and within these files, you need the DIC and the LM file. Yes, so you will have the LM and DIC. So these are the two files that you need for this LM work. So you can extract to any you can extract to any place as long as you're able to point this file when you run your LM. So you need to specify the location in your when you launch your LM file. Okay, so we have the 6220 here. Right, so we can use this for you can run all over again and point it. Okay, but instead of running the convention way, we show you how to write this path into your launch file. Okay, so now I show you the second way of running. So we are going to run the same thing, but instead of running the whole very long command line, we're going to write the path into the launch file. So David, you can follow the last step. So we first find our launch file. Okay, so in the launch folder, so we gedit, we modified the lm.launch. Over here, you can see there's a lot of argument name and so on, but you can see there are two. One is DICT and one is the LM. So these are the two arguments that you want to specify the value. Okay, so by default, the value for DIC is, okay, so you just need to write down the path point to your DIC file. And for the LM, similarly, you write the path point to your .lm file. Okay, so maybe I'll show you how to do that.
I will copy the command. Copy this one. In if you want to copy something, you cannot use the Control plus C key. You use the mouse right key to use a copy. And Control V. I change the file name to
6220.
This one.
Yeah, 6220.
You can change the name of this file. No problem.
Okay, so now once you already modified the launch file, you can see like the next time when you launch the launch file, you no need to specify the DIC and the LM file anymore. It's because it is already written in the launch file. Yes, and it runs the 6220 database.
Yeah.
Right, so that is how it is. Yep. Yeah, okay, you want to try again?
Let me try again. Bring me the glass. Could you? Okay. Bring me the glass. Good job. Thank you. Stop. Stop. Come with me. Come with me. Go to the bathroom. Yeah. Okay. Thank you.
Okay, so you can see like, yeah, it's pretty much better now. And because the database is smaller and yeah, everything's just much better. So over here, just let me add one more is the way how you modify or create your database, and also the entry of your database. For example, you have very different way of writing in your database, or very similar. If you have too many very similar entries in your database, it's actually not good, because it is very easily to get confusion. Okay, because the system might not show whether it's A or B when A and B are very similar, right? So you need to put a lot of it requires a lot of experience, okay, to play around with the database, your mic setting, and also how your logic to filter out the false detection and so on. So these are all very how to say, you need a lot of practice and also experience in order to improve your detection accuracy. So that's what I say. There's no a magic way that you can like use the system and without do any setting and it will give you perfect recognition. There is no such thing in this world. But there are actually many efforts in this that can provide you a better services, which is the online approach will give you much more better result. It's because like they have a very big team, engineers and so on, to help you to improve a lot of aspects. For example, like we don't have any noise cancelling in our mic. So we have a lot of noise entering to our sound card and to our detection and so on. So the noise cancelling and also the logical filtering and so on. So these are the things that we didn't do in our system, but we need to put all these things in. But for the online system, for example, if you're using Google API or using Baidu later on, or any Xunfei or anything that later on David will show you, they actually have a lot of other things happening to actually improve all these little aspects. Okay, so later on, David will show you the online way for certain tools that you can see, you can compare how accurate. And also David will show you how to use the online tool to do the English one. So which is we want to show the example that this speech recognition, and for our system, we can easily change, not to say easily, we can able to change the system to adapt to different languages as well. Okay, but before I end this speech recognition explanation, I want to explain to you the source code implementation. So, but before I tell you about the source code implementation, David, let's go to the assignment. The next slide. So for the next slide, so now I want to tell you the assignment for this week so that you can understand the requirement, so what you need to develop. Okay, so the assignment for this week, can you like put it bigger? Okay, so for the assignment, this time what you need to do is you are going to combine the speech synthesis and speech recognition into one single application, right? To develop a robot speech question and answer system. So this assignment, you need to create a robot system that able to do Q&A, question and answer. Okay, so in detail is design and develop several question. So this several question is for your speech recognition. So you can create a database to recognize question. Okay, so I give you all the tips. You modify your database to recognize question. Then you are going to also develop the answering system by using your speech synthesis. So now you are going to write in your code what is the answer for particular question and let your robot read out the answer by using the speech synthesis module. Okay, so you try to design this in a question and answer test. And the theme for the question and answer is for the robot self-introduction. For example, you can write out the question, for example, like what is your name, where are you from, how old are you, who is your father, and so on, right? So where is your hometown? Okay, you can design this question, and you can write out the answer for the robots. For example, like, okay, so what is your name? You can design the name, you can design the hometown, you can design the age, you can design anything. Okay, you can design. So this is based on your design. So you need to do these two modules together and try to run them together so that you have the speech synthesis and the recognition run on the same time, so that when you ask the robot certain question, it will recognize, and the result of the recognizer will flow into your system that do the speech synthesis, which means then you need the logic to understand or to how to say, to identify which question so that you can give the appropriate answer. Okay, so how to do that? Now I'll give you the tips. So please go to the talkback example. Okay, so now I roll back the slide to the speech synthesis page. You show the slide for the speech synthesis as well.
You want me to change
yes.
the slide to the...
Yes. Hey, talkback, not the speech synthesis, sorry. The front one, yes. Yes, this one. Right. So over here for the KWS, actually, I have an example called talkback. Okay, so over here, the talkback. So on the right-hand side, I show you the source code for the talkback.py. Okay, so what this talkback example works. So how it works is actually, this talkback will listen to whatever you say and try to recognize what you say and try to say the same thing out. Okay, so let's start from the very top part. Okay, so we create this node and we initialize. So this one, okay, we have the sound client. So you can see this node itself already have both recognition and synthesis. So I will combine the synthesis and also recognition in one node. So this talkback already have this all this. Okay, head to the subscription. Down a bit. Okay, so you can see like in the initialize function, the last one is ROS.py subscribe to this KWS underscore data. So I'm using the KWS data, but for the assignment, maybe you want to use the LM underscore data, right? So with this line, you can straight away subscribe to the result of your LM. So what you need to do is like you just need to change the database of the LM into your question, and then you subscribe to the LM underscore data. Then you will get the result from the LM recognition. So this is how we do it. Okay, then let's look at what happened after you subscribe. So we have the talkback. So let's look at the talkback function down there. So the talkback function is once you receive the result from the LM data, which is your recognizer. So what the robot do is it just print out the message, which is over here. You can see talkback, then ROS.py log info, which is a print out, and then the robot will we will do the sound handler for say, which is your speech synthesis, to say out that I heard something, which is whatever you heard. And then over here, I specify another new argument, which is the volume. Why I put the volume very small? Instead of 1, I put 0.01 is because I'm not sure what is your mic and speaker configuration in your PC. Because if your mic and speaker is near to each other and you put your volume to 1, most of the cases, your speaker is going to, send the voice back to the mic again. And you will have the echo, which is not so nice if you run it on that setting, right? So I understand that some of the laptops you might not able to reposition your mic and speaker. So the only way you can do is you need to like adjust the volume, although it is not so nice because 0.01 maybe you can't hear what the robot say as well. So you want to like adjust the volume. So over here I put in the code over there for you to adjust, just in case you cannot adjust your speaker and mic. But if you can move your mic and speaker in a different direction, you can try to increase the volume without much problem. Okay, right. But over here, this talkback is not enough for your assignment. It's because it don't have the logic to understand or to figure out what is the question inputted from the user, because it just read out whatever that it hear. So you need to add an extra layer of logic in order for your system able to recognize what is the question currently being asked. So in order to do that, I will show you another example, show you the kids. Okay, David, show the partybot.py. So if you go to our example, Ross example, and inside there there's application, we call it the partybot application. Okay, so you don't need to see this whole file because it's a very long one, but all you need to do is just to head to the part where it is actually under the talkback. Yeah, I'm using the same talkback also. So it's under this talkback function where you can see over here, I try to recognize certain input. Okay, and I'm not recognizing, or I'm not trying to compare the logic using the whole sentence. I just pick up the keyword. I just say if your sentence or the recognizer detect something or hear some keyword, for example, the keyword is introduce yourself, or how old are you, or something else, are you from, or where are you from, and so on. So if it contain the keyword of introduce yourself, then you start to say like, okay, I heard you want me to introduce myself, I'm blah blah blah, and I'm doing what and what and what. Okay, or the how are you is like, I heard you asked about my age, I'm 5 years old, and so this is what I want to show you. I show you the if-else ways of try to pick up certain keyword. So the strategy is you just pick up keyword. You don't try to recognize or try to compare your logic with the whole sentence, because your recognizer, most of the cases, will never give you 100% accuracy. So the strategy is try just to pick up the keyword and guess the question based on your keyword, because this assignment is a finite set of Q&A, right? So you can just use that to of course, if you want a very good system, your database have to be very big, but that is another issue. So how to scale your application and so on. But over here, I want you to exercise the fundamental thing on how to create this whole system and framework. Okay, so with that, I think I've given you all the necessary things in order for you to do your assignment for the speech recognition and also speech synthesis, in order for you to create an application for robot speech interaction. Okay, so I think I've come to the end of my presentation today. And lastly, I want to tell you about this. Okay, so for a speech or chatbot, speech interaction and speech synthesis is not the whole system. You actually require much more things. For example, I list down some of the possible module that you need to add in. So if you look at the diagram, this is the whole system that you want to develop. So we have inside there, we have the speech recognition and speech synthesis, but we also have other things. Okay, we will put the sound detection and localization apart. We'll talk in other time for that. But over here, what we need, or what is missing in my presentation, is this part called speech understanding and dialogue manager. So you need another system in order to understand what is being asked and how to generate the appropriate question, because you're not going to list down all possible question and answer for your robots. That is not easy. Of course, I have another system which is I have another chatbot system we call the AIML to do such thing. But I think later on, David will show you another way to do this, like dialogue manager and speech understanding as well, using the online way. Okay, so there are many things else that we can learn in order to do the speech interaction for robots. But today I just give you a very simple explanation and also example of the detection and recognition. So I'll pass this session to David to show you some other thing, online system, Chinese language recognition and synthesis, and also he will show you a demo on this dialogue manager and so on. Right, so David, I'll pass the session to you.
Okay, thank you. Thank you, Jeffrey. Thank you, everybody. Now I will introduce, I have a few minutes to introduce iFlyTag, means 讯飞 iFlyTag voice interaction online system. 讯飞, I mean, iFlyTag is a very famous company in the AI in China, maybe in the world. And they also provide some ROS package to help us to develop some very interesting application. Use the voice interaction. There is some nodes I have print here. You can run this command, RoboCup and xfei ASR node, and this package and this node, and you use topic pub to send the words to the speaker. But you can change the Chinese words 你好 means hello. How are you? In English words, the nodes also can speak in English, but the English pronunciation is very strange because this is a Chinese mothering engine of the voice. So of course it has a English voice engine, but it's for me it's it will need to pay for the English speaker. So if you want to use, for example, Google, maybe it's much better for you to use the voice engine in English. And this also has a node to recognize speech recognition and to recognize what you have said in English or in Chinese words. And the most interesting I want to show you is a Rose voice system, which has been already set up in installed in our VirtualBox image. At this position, you can find a workspace names Rose voice system. It has three parts of the main three parts. First is the speech recognition, and the second is I can call it brain of the smart speaker. It's also a web platform to recognize what you have said and give the answer to you. So I will show something about this. I can call this smart speaker. Okay, we can use this command Rose launch voice bring up, and this is the packet name voice bring up launch. This is the node.
Your Peter voice interaction system started successfully.
This means Jupyter robot voice interaction system start successfully. And I want to use 唤醒词，陈老师，唤醒词怎么说 ？Wake up words. Yes, wake up words to tell the system. The wake up words we use is a Chinese word, but I think you can pronounce 木星. For the first time to wake up the system, maybe it will need more times. 木星. Oh, 木星. I need to change the setting of the microphone. Wait. Oh, wait. Oh, I forgot to input the. Wait. Okay. Wait. Okay. 木星. Oh, here's come. 木星. 现在时间是多少 my question is what time is it now? Uh-oh. 木星. 现在几点啦
？2020年4月30日，星期四。
木星。
55。
How are you?
你好。
木星。
你好。
木星。Nice to meet you.
很高兴见到你。
So for English input, the system will translate the English word to Chinese words. It didn't have a function to to say something interactive with English, but it will okay for Chinese words. I will try much more. 木星，你来自哪里？ The question is where are you from?
我
The
的
answer
家
is
在
from
浙江
Jiaxing
省嘉兴
province.
市。
浙江 province Jiaxing city. 木星
The question is, where are you from? The answer is that from the province city.
This is Chinglish pronunciation. Okay, I think that's all. Jeffrey, that's all. Thank you.
All right, so thanks for the demonstration, David. And just for the demonstration, I mean, like maybe you don't understand Mandarin and so on, but you see the interaction and so on, the tools. So currently, maybe the tools is not set to respond in English and so on. For example, like just now the wake up words. The same thing, very similar. We can find tools to replace. For example, you can use the OK Google, which is the wake up word for the Google API speech system and so on. And we can use a lot of this chatbot system available on the web. So all we want to show is the possibility for our system to incorporate with this kind of system from the cloud. I mean, you can explore. There's a lot. Google API, Amazon, and a lot more you can input, and also in your mother tongue. Okay, for example, I'm not sure over here. Maybe we have friends, and also we have users from other parts of the world. You want this speech recognition and also speech interaction system in your own mother tongue, native language, and so on. We have the framework to do this in offline, online. The podcasting is able to convert to other languages as well. The one that online you can tap to a different API and you will give you a different languages as well. So from there, what important is you learn the whole concept of how from the synthesis to the recognition and understanding, and that is how we can create the whole intelligent speaker system, right? So the one that you have in your intelligent system or your phone, like Series and so on. So we can actually develop this whole thing with the resources and also the system that we introduced to you. Okay, so I think that's all for today's content. Thank you for your participation, and we can open for some Q&A if you have anything to ask. And I will encourage you to like share this thing with your colleague and peer and encourage them to join us later on. So this video I will up again on the website, and also from here I show you the entry form. So please help me to spread this news to all other of your peers, colleagues, students, and so on. And if any of your teams want to join our competition or considering to join our activities and so on, we encourage you to really do the sign up as soon as possible. Is because we are sending email to only the teams, particularly on the specification and also some additional detail for the competition, which is we won't do a lot of spamming on public mailing lists for all the announcement. So if you want a more latest updates about our activities and so on, we appreciate you to do the sign up first, right? And also thanks for joining today, and please share this thing with your colleague, peer, students, and so on to make sure that we will have more people that we can learn together. Right, so with that, I will say thanks to you. I will keep the Zoom for a while. If you have anything you want to ask offline, I will stop the recording soon. So thanks for coming, and hope to see you again next week.